In the previous lesson, Mary and Claire explored how they could modify the sine function to create a function that gives a person's height above the ground as they traveled on a Ferris wheel. This required multiplying the sine function by the radius of the wheel and then adding the height above the ground of the wheel's midline. In this lesson, they will explore how to transform the sine function so that they can model a situation completely unrelated to height. They transform the sine function to create a model of Houghton's average daily maximum temperature as a function of time. They begin by exploring an applet to investigate how various transformations of the sine function affect the shape of its graph. In particular, they adjust the values of a, p, h, and k in the equation on the screen and notice the effect of these adjustments.
And so I'm wondering if you can use the sliders to change the values and sort of see what happens to the graph as you move the sliders around.
So before we touch anything, based on what we did with the last one, I think it's safe to say that A is always like the radius. And
plus K, I wonder if plus K is down here, like this.
Well, K is like the center of this graph is like this right here is, this tippy top part is the top of the circle, like the maximum, and this is like the minimum, so like right in between there, like, oh, here, right here. That's the center of our circle.
Okay.
So K is always is like the height to the center of the circle.
I see. So what do you know that it is based on your graph?
Here it's 32.
I see.
Now should I change it? Let's change it to see if we're right.
Yeah.
Yep.
We're right.
That's good.
Woohoo.
All right, I'm going to change these values here so that way they better correspond with the graph that we'll be working on next. Okay, so K moves it up and down.
And A.
What does A do?
Oh, A makes it smaller and bigger.
Yeah, because that's the radius.
Oh yeah.
It's like how big the radius is.
It's like from here.
From here to the center. Yeah.
That's what A is. So if you make it smaller, then the radius is, wait. Oh, that's
okay, you're going to negative values, yeah.
Well, look at, they're tiny little radiuses, so it's making them a little tiny.
Radiuses.
Right. It's so cool. And negative, it gets bigger too because it's a bigger number for the radius.
Yeah.
Can we make it, it's like a mouth.
It's like negative, you're turning the circle upside down. What does P do?
Makes
spaces it out. What does P do? What does H do as well? Because maybe we can use that to figure it out.
That's so cool.
Starting point.
Oh, yeah.
I think H is your starting point.
Let's use it back and forth.
Because it's...
Watch this. That's so cool.
Because like here, this 0, the y-axis, that's where you're starting on the circle. Like that's sine 0, basically.
That's so cool.
So I think H is like if you're starting anywhere else, that's why it would move.
Because K, you said, moves you up and down.
Wait. Okay, let me think. So if that one is...
left and right, left and right, left and right.
Wait, but if this one is like 0, then it's moving up. Wait, it's moving up, over, and it's getting to a higher point that it's starting, and then it's going down. Oh, it's not moving. It's going down. You know? It's like starting lower, and then it goes around the circle, and so it gets to a higher point that it's starting, and then it goes back down, and so it's a lower point that it's starting again. Like it's following the circle.
In this episode, the students used an applet to explore how changing A, P, H, and K affected the shape of the graph. They noticed that adjusting A stretches the graph vertically, adjusting P stretches the graph horizontally, Adjusting h shifts the graph horizontally, and adjusting k shifts the graph vertically. In the next episode, the students will use the applet to generate a function that models Houghton's climate.